Here if we see on this add function, we have this number type. So this is the return type. So this is the type of this return which we have in this add function. So because we are passing two parameters as number type here, so TypeScript infers that the return type will also be a number. We can specify that here, but we don't have to do that because TypeScript infers that on its own. We can convert the return type to string here by using toString also, but, but this is what it infers on its own. That if we are adding two numbers, then it must be a number. Now here, if we have another function where we pass one parameter number type and we console log this result and pass that number, and then we print that we use that print result function, and inside that we pass the add function where we give two numbers 5 and 12. So this will print console log this statement result and the number which is 17 here. But when we do this console log on this print result, this will give as undefined because this print result function is not returning anything. So in JavaScript, if a function is not returning and we do this, we do something with that function, so this will be undefined because here we are not returning anything. So this function returns a void type here. Void type is not present in JavaScript, but we can use that in TypeScript here, where we don't return anything for this function. Now we can also use functions as the types here. For example, when we want to add, we have this add function that we want to assign this to another variable here, and then we want to use that after that in, for example, printing this statement, and we want to pass the new function with the assigned value of this function that we created here before. So we can do that in JavaScript here, but after that we can also, for example, pass a new value here. We pass a number to this combined values that we created and passed this function before. So this will not generate an error here, but this will be an error when we run this. So this will give a runtime error. So for that, we can use function as the type. So while creating this variable combine values, before assigning it the function, we can pass this function type here by using this bracket and then this arrow. So this is what it returns. So we tell that it returns a number, and here we pass the parameters. We can leave this empty, then we don't pass any parameter here. But here, for example, we pass this to A and B, which are both numbers, and this returns a number. So now when we try to pass this, for example, value here, so this will generate an error here in the TypeScript compiler. So this is how we can use a function as a type here. Now, for example, we create another function here. We pass two parameters of numbers, and then we pass a callback function in this that we want to give the parameters of the result here. We want the callback function. We call that here, and inside that we pass this one parameter which is of type number, and then it returns a type void. So this does not return anything. We are not interested in a return here. So then we use that here. Now if we pass a result here, and it does not return. So we console log the result here. So this is how we can use the callback function. Here we can also have a return statement which will not generate an error because we can return anything here if this is void. We are not interested in the return statement with this callback function, but we can have that return statement here. What this cares about is the parameters that we pass here. So this should be a number because we defined that, and we cannot pass another parameter with this because there is only one parameter in this callback function that we are passing. Another type that we can use here is the unknown type. So for example, we create this variable and pass this unknown type here. So then we can put any value here. It could be a number or a string or a boolean or anything because this is the unknown type. But then if we try, for example, we pass this username as a string type, that we cannot assign this username to user input because this will give an error then that it is not assigned to a string type because this is an unknown type. We have another type which is any type, so we can have anything in there, so that will not give an error here. This unknown restricts this to a certain extent. So we can have this if statement here. If type of input user input is string, then we can assign that here the username because with that is the string type. So we can use unknown like this in TypeScript. Then we have this never type. So for example, we want to generate an error here. We have this one message of string and a number code. Then we will throw an error with message and code here. So we uh, use this function here and pass the string and code. So and when we run this, this will throw an error because we have passed the parameters. So this is the type. This never returns anything. So we have it has this never type because it does not have a return statement. It does not complete this script here. This is different to void type because that does not return anything, but the function still runs. So, and but this crashes the script here. So now we can have some configuration for TypeScript. For example, we don't want to change this. We don't want to run the TSC every time we make some changes here. For example, if we want it to run in watch mode, so whenever we make any change to a TypeScript file, it automatically compiles that to this JavaScript here. So for that, we can run this command tsc app.ts and -w. This will run this in watch mode. So whenever we make some new changes here, it will automatically compile that to the JavaScript file. If we have multiple TypeScript files in our project here, so if we want all of them to run together, if we want just to have one command here so that all of them compiles to the corresponding JavaScript file. For that, first we initialize this TypeScript here, tsc and dash dash init. So this initializes in our project and creates this configuration file, the .json file it creates for configuration, and then we can run this tsc command by itself. So this will then compile all of these TypeScript files to their corresponding JavaScript files. Here we configuration file. Then here we have a lot of functions that we can use. For example, we can exclude a file or folder here by using this exclude, and inside of this we pass the name of the file or the folder. For example, we have a node dependencies in this node module folder. So if I run this tsc command and I don't want this folder to make any JavaScript files and I don't want this to run, so I can pass the folder or file name here in this exclude. Now if I want we can also have include here. If we want to include some files, then I have to specify all the files that I want to include while running that. So we can use both of these. We can use both of these together also. Then we have this target. So here, this is the latest, the JavaScript features that we can use in the browser. So we have ES6, but the version that this compiles to. So we can use the ES6 features from JavaScript here by using this. So this is by default here. And this module defines the module system that it uses. By using this lib, we can pass the name of specific libraries that we want to use. For example, here we use this button. We create a function button and we pass this document.query selector. For example, we create a button in an HTML file and we want to use that here. So this is the DOM in JavaScript. So these are the properties of DOM that we have in JavaScript. We can use them here. We don't pass that. So this can give an error. How will it know that there is a button present? Then we can use this exclamation mark. So if we don't know that the button exists here, so how will TypeScript know? So we can have if statement here, and then we perform this add event listener on button. So we can have this exclamation mark. If user specifically knows that the button is present, so to prevent that, we can have this DOM in configuration here. We have this out dir and root dir. So this out directory. So for example, we want to compile all the JavaScript files in a separate directory. Then all these TypeScript files to have a clean structure here. So we create a new directory here and we pass that here in out directory to get the output of the TypeScript files, but it compiles to a certain directory. We pass that here. And this is the root directory. So of the all the input files will be present in this particular directory. So to have a cleaner structure here, you can use this. Then we have this remove comments. We can set this to true. So whenever we compile a TypeScript here, so this comment, when this file compiles to the JavaScript file, this will not be present here anymore. So we only see these comments in a TypeScript file. We can remove them from the JavaScript output file using this. Then we have this no emit on error, which then if we set to true, it will not produce the output file. It will not convert it to the JavaScript file if the errors are not resolved. So if there an error here, we can uh, we can still compile that to the JavaScript file. But if we set this to true, we will have to resolve that error in the TypeScript file before we compile that and get the output of the JavaScript file. So this is the configuration that we can do to make sure that the errors are resolved. Then we have this strict type checkings. So we can set this default is to true. So all of these are true by default, but we can choose each of these separately to check and see inside this strict type checking. First, we have this no implicit any. So this can be used to raise an error when a type is set to any, which is not good for TypeScript because we want to see when the errors are coming. If we just have any type, so we can use any type, can pass any type, number, string, or anything here. So when it infers the type of a variable or a parameter as any, so this will raise an error if we set this to true here. Then we have this string null checks. So this checks that the word undefined are only assigned to themselves. If we have a void type, then that will not be assigned to any other type after that. Strict function types to true make sure that the function types are checked correctly when functions are called and used. Strict bind call apply when we use bind here. So this will enable strict checking of that. For example, we create another function here with where we pass the string and we print that with the console log statement here inside of this function. Then here when we use bind in that function, we pass that in this add event listener button that we were using. So we will have to pass this null here. Since we pass the parameter as string here on this function, so using that with bind here, we have to bind this with this. So then we will have to pass only string here. So if we just pass the null parameter here, null type here, if we don't pass anything, so this will generate an error. If this is set to true, if this is set to false, then we can pass the null or anything here. Otherwise, we have to pass a string here, which is the parameter that we which is the type of the parameter that we defined here. So this is a strict checking by using bind. Additional checks here. For example, this no unused locals set to true. So if we have some unused local variables here, for example, we create a local variable and assign some value here, and then we don't use that anywhere in our code after that. So if you set this to true, this will generate an error that there are unused local variables. Similarly, if we have unused parameters, so we can set this to true. So this will make sure that we generate an error when we have some unused parameter. We pass a parameter here and we don't use that. So we can also set this no implicit returns to true. So this will generate an error when all the code paths don't return a value. For example, we have this function here with two number types parameters passed. So if this is greater than zero, we will return this. But if we don't have this else return value, so if we just use return statement with this, if it is greater than zero, so for everything we are not returning anything. We are only returning for some here. So that will generate an error. We need to have a return statement for every condition here by setting that to true. So now we can have this let const or variable that we can create. So for example, we create a variable with this let. So this is beneficial over variable which was used before in JavaScript because it binds whatever variable we create inside of this curly braces block. And for constant, we cannot change its value after that. So both of these can be used. We also have this arrow function that we can use to assign this. We have these parameters that we pass, and then this should return to a plus b. If we have just one expression here, we can use just this without the return statement here. So we can have this.